Hi guys, this is going to be part 2 of the video that I did last week, USACO 2020 December contest, and we're going to be doing problem 2, DaisyChains. Let's look at the problem first, as always. Every day, as part of her walk around the farm, Bessie the cow visits her favorite pasture, which has N flowers, all colorful daisies, labeled and 1 through N lined up in a row. Flower I has P of I petals, with P being 1 through 1,000. As the budding philosopher, Bessie decides to take several photos of these flowers. In particular, for every pair of flowers, I and J, satisfying I 1 is less than I is less than J is less than N, Bessie takes a photo of all the flowers from I through J, including I and J. So it's going to be take a photo from I through J, from I plus 1, I plus 2, all the way to J. Bessie later looks at these photos and notices that some of these photos have an average flower, a flower that has P petals, where P is the exact average number of petals among all the flowers in the photo. How many of Bessie's photos have an average flower? Okay, so the input format is going to be the first line of input contains N, second line contains N space integers of P of 1 all the way to P through N. And output's going to be the number of photos that have an average flower. Okay, sample output as seen here, following this, and sample output showing this. And let's look at this a bit later when we know what the problem is saying. Okay, let's go on to iPad and just explain what the problem is supposed to be. Let's say there's 1, 2, 3, all the way to N. Right? Why did I put that so far? 1, 2, 3, all the way to N. And all these flowers have some kind of petals. I equals to some number. And let's say we had a pair I comma J, which equals to 2 and 5. Okay? And let's say flowers 1, 2, 3, 4, 5. The number of petals is going to be 2, 4, 3, 5, 6. Let's make this actually 2, 6, and add a 6, which is gonna be 7. Okay, the average of number of petals here that is talking about is gonna be sum I equals to 2 all the way to 6 of basically P of I divided by 2 minus 6, which basically saying here we start at 2, so all the way to 6 is going to be 4 plus 3 plus 5 plus 6 plus 7. If you don't know what this means, that's fine. It's just mostly for the people who do have a math background and know how to interpret that. It's easier to look at it that way. So basically, IJ 2 through 6, average flower is going to be this. Wait. No. It's going to be 6 minus 2 plus 1, since we're including both. So it's going to be 5. And that makes sense because 1, 2, 3, 4, 5. And the average here is going to be, let's say, 10, 20, 25 divided by 5 is 5. Okay, the average number of flowers is 5. And is there a flower in this range where the number of petals is 5? Yeah, it's right there. So in this case, we would add 1 to the answer. And if we were to do this for every single combination of I and J, at the end we print the number of averages. Or the number of photos that had the flower with the average amount of petals. Okay, so let's go on to actually solve this problem now that we know what we're talking about. If we have all these petals, here's a very important thing that is useful for a lot of problems. When we have to find the sum somehow of a long list of integers, a lot of times it's very inefficient to find that sum every single time. Because think about this, right? If you were to have I comma J of 1 through 1 million, or 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, a million. That means that we need to make a for loop that sums up these things, and that's gonna take a million. I'm having trouble writing a million without any commas. Okay, a million. Okay, that's actually wrong. Okay, there you go. A million times, right? We need to loop this a million times. And let's say the next thing that we want to check was 999,999. In this case, we will need to do the same thing again, except don't count the last one. There's gonna be a lot of processing power. So what we like to do is take a look at this. Let's say we had a list from 1, 4, 5, 6, 7, 8, 9. And what we're gonna do is let's say these values are A, B, C, D, E, F, G, H, I. And how we're gonna do this is we're gonna pick a new array, okay? Sum array. The first one's gonna be A, second one's gonna be A plus B, and A plus B plus C, all the way until we have A plus B plus C plus dot dot all the way to plus I. Right? So using this array, what we could do is, let's say we had a I comma J of 0, no, not 0, 1 comma 6. And obviously we could just take the number that's here, which is going to be the sum of A through F, right, for the sum array. But if we had 3 through 6, what if this, you might say? What we could do is we could take 1 comma 6 and subtract 1 comma 2 and get 3 through 6. So in this case, what this would mean is that we take sum of 6 minus sum, that's not how you spell sum, and subtract 2. And this will give you what you need for the sum. And obviously, if you want to find the average, you would take this number and you just divide it by 6 minus 3 plus 1, like we did before, up here. Okay, that's basically it, like for the tricks that you need to solve this problem. If you know how to do that, rest of it's gonna be pretty simple. What you're gonna do is make the sum array, find every single number in the sum array, and then go through every single pair of I and J and find the average, and then see if that average is within the flowers that you have. Let's go into actually coding this problem. This might take a little bit longer than do you know your ABCs. Okay, let's create chains.java. Oh, okay. No, what I'm gonna, okay, I shouldn't show that. What I'm gonna do this is I'm just gonna delete this because I don't really need this anymore. Okay, DaisyChains.java. And as always, copy and paste this setup. And there we go. Okay, first of all, as always, we take our inputs. The inputs are gonna be, first line is n, and the next ones are gonna be just that. Okay, so int n is equal to that, and then we're gonna do tokenizer equals to new string builder, because we're going to the next line, string tokenizer br.readline. Okay, now that we have the same next line, what we could do is make an array equals to new int array of n, and we're also going to have the sum array as we said before, and this is going to be initialized in like the same, you know, time as the r. So for int I equals 0, I is then n. Okay, I'm trying to code with like these spaces to make it easier to read. It's a good habit to have. And let's say r equals to that, sum equals to sum of I minus 1 plus r of I. And that should be right there. And obviously, we don't want this to... Oh, that was happening. What do you mean? Oh, I didn't put an array sign there. That's fair. Okay, obviously, if we do I minus 1, it's going to give us an error because we start at 0. So what we're going to do is set that to 1. And we're going to do I of 0 equals to that. And sum of 0 equals to R of 0. I can't type today. What the heck? Okay, there you go. Awesome. So that's going to be it for our inputs. And now we actually to get to the logic. And as we said before, what we're going to do is just go through every single iteration of I and j that we need. So for int I equals 0, I is less than n I plus plus. And for int j equals to I, j is less than n, j plus plus. And what we're going to say is, it's going to become clear here. It says here, every single picture with just one flower contributes to the count, right? Because if there's only one flower, obviously that flower is going to be the average. So what we could say here instead is just, if I equals to j, and let's put a int ans equals 0, ans plus plus, and continue. Okay. And for every single one where that's not true, we actually need to do the logic part now. What we're going to say is int average equals to, actually, let's initialize this outside here. Average, just that. And average is equal to sum of j, as we said before, minus sum of I, right? I minus 1, because it's including that number. So what we're going to do here is just, we're going to start, okay, we'll figure that out later. Okay, average is going to be that plus that, divided by j minus I plus 1. Okay, cool. So we have the average, and what we're going to do is we're going to just go from, let's call this count equals to I, and count is less than or equal to j, and count plus plus. And we're going to check if average is equal to our count, and if that is 2, we're going to do, oh, that needs to be double equals. We're going to print, or not print, what am I saying? We're going to add 1 to ans, and that should be mostly it for the continue, and that should be mostly it for the logic. But some of you guys might have caught here that if we have I minus 1 here, and I could start at 0, then that's going to be a bit of a problem, right? So let's make a new thing for if I equals to 0. Let's do something a bit different. So if I equals to 0, as I said, in the iPad here, we could just, let's see. Yeah, I equals 0 here is just same thing as I equals 1. So let's say we had 1, 3, right? Average is going to be sum of 3 divided by 3. Okay, so let's just do that. So here, let's just have here for, actually, no, let's not do it like that. Actually, yeah, let's just do it like that. Okay, so for j from I, I'll do it to n. If I equals to j, ans plus plus always, and average is actually going to be equal to sum of j divided by j, I think. No, it's going to be j plus 1. And just like that, it's going to be all the same things here, I believe. Yes. Okay, cool. That should be it for the problem, I think. Let's do that to make it better to read. That should be it for the problem here, and just output. This one, output's really simple. We just do pw.print ends. And for the setup that I used today, this file, I'll also put that in the code backlog available in the description. So let's test this, right? Terminal, as always. So let's just hit here. Yes, so Java DaisyChains.java and Java DaisyChains. And let's put in the sample input here, which was this. And it gives us an exception. Let's see. Line 51, index out of bounds. Let's go what's happening there. 51 here. And now. Oh, okay. We just need to continue. I accounted for the 0, but I didn't put a continue, so it just ran this anyway. Okay, let's save this and let's do that again. Oops, I didn't mean to do that. Oops, okay, let's do that again. Java DaisyChains, and let's copy the input again. Put that in, and give us 13. Something's not right. Okay, in these kind of cases, we need to do some troubleshooting, and that's normal for coding as general. Let's see what's happening here. Let's just print both I and j whenever we have a answer addition. So let's do this and also add this onto here. Add this here and add this here. Okay, let's try that. I'll just run it from here just to make it simpler. Copy the input. Get that in there. Okay, so all these are the ones we're going to count. 0, 0, 0, 1, 0, 1, 0, 2, 0, 2, 0, 3, 0, 3, 1, 1, 1, 2, 1, 3, 2, 2, 3, 3, 3. Okay, one thing I'm noticing here, every single one that starts with a 0 except for 0, 0 is getting counted twice, which is a bit weird. Let's see what's happening. So if I is equal to 0, we go into here. And when I equals to j, which is 0, 0, it caught here, gets caught here. And average is that. Okay. Oh, I see the problem now. Okay, so in this for loop, instead of a continue, we need a break, because if we found the flower that's already equal to the average, then we just add 1 to the answer and that's it, right? So let's put that in here too. So like this kind of print thing is like a strategy that you would use a lot just for troubleshooting. It's just very handy to have on hand. Let's put in the input again, and it still gives an error here of 10. And let's see what the problem is. So 0, 0, 1, 1, 2, 2, 3, 3 is all supposed to be there. But I don't see a 4, 4, which is concerning. Actually no, I shouldn't see. So 0, 0, 1, 1, 2, 2, 3, 3, that's already 4. What am I saying? Okay, so let's see what's not supposed to be counted. 0, 1, that should be counted. 0, 2, that shouldn't be counted. 0, 3, that shouldn't be counted either. Okay. 1, 2, that shouldn't be counted. 1, 3, that shouldn't be counted. 2, 2, that should be counted. Actually, no, 1, 3 should be counted. 2, 3, that should be counted, and 3, 3 should be counted. Okay, it feels like our logic system just isn't working. And I think I know why. Okay, so when we do this here, that's gonna give us some decimal, and we're paying attention here. You'll see that average is an int, so this decimal just rounds to the nearest whole number, which kind of breaks down our whole system. Let's turn this into a double, and let's also convert all of these to doubles. Okay, that number double, and divide everything here, and let's turn that into a double as well. Okay, and same thing here. That's gonna be like this. Anywhere else where we count? Okay, and just to avoid errors, let's put a double conversion right there too. Anywhere else where we're using average? Here, 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 here. And that should be it. Okay, let's try that again. And that gives us 6, as expected. Nice. So, let's try it in the terminal one more time, just to make sure nothing's like completely destroyed. Java, and then put in our input, and that should give us 6. Nice. Okay, let's put that into Java here. Choose file, and we know it's gonna be DaisyChains. Upload solution. Am I not logged in? Okay, just a second. Let me log in. Okay, I'm back. I have logged in, and let's do that again. DaisyChains, upload, and some solution. Hopefully this will work. Oh, I forgot to get rid of the print statements. Let's get rid of this print, this, and this. Okay, is everything correct now? I believe so. Let's try that. And that's not what I'm trying to paste. Let's take this and paste it on here. And we get a 6. Nice. Okay, wait, why is it still printing with those? Where's our print statement? Oh, I forgot to delete this one. I see. Okay, let's try that again. And that's it. Okay, cool. Let's now submit. Yeah, when you decode, this happens a lot, or just forget to delete stuff. Okay, grading in progress, and everything is correct. Yeah, that's mostly it for this problem. That's gonna be pretty good. All about 70 milliseconds, which is actually surprisingly fast. That was faster than the previous problem, which was technically more complicated. Okay, so that'll be it for today's question. And as always, you can find the solutions in the code backlog document in the description. And I'll see you guys next time for what's the next problem called? 2020 December. I'll see you for Stuck in a Rut. Bye bye.